This is a 4-hole sp3 carbon atom with 4 magnets inserted, so 2 north poles and 2 south poles are facing outwards. And here we do a quick confirmation that the poles are inserted correctly using a magnet probe. Now we see beside it a methane molecule, but for simplicity and speed of demonstrating, we won't use the hydrogen atoms. Here we've prepared 6 carbon atoms, each with their 4 magnets correctly inserted. We are now ready to build some simple alkane models to help us understand UPAC naming conventions. We'll start by putting together 2 to get ethane. We add a 3rd carbon atom to build propane and move it around a bit to show how strongly the model holds together. Note again the free magnet ends where we can add hydrogens if we want to use them. Now, add a 4th atom to make butane. Then remove it and add it to the middle carbon to show our first example of branching, 2-methylpropane. We then move the methyl group back to make butane again. Take another methyl group and attach it to one of the inner carbons to make 2-methylbutane. Add the remaining methyl group and we now have 2,3-dimethylbutane. Take a step back by removing the 2 methyl side groups. Here we begin with 5-carbon pentane. Add another methyl group to create 2-methylpentane. Move it to the middle carbon atom to make 3-methylpentane. We then take the 6-methyl group and add it to the end to make hexane. Note how stable the model is as you rotate the atoms. Now let's have some fun by connecting the ends to make cyclohexane. We start with what's called the chair conformation, which we can see as we move it around. Give the model a slight twist and feel the resistance analogous to the lowest and stablest energy state. Hold atoms 1 and 3 and do a chairboat flip. This may take a little bit of practice to do smoothly. But here's where the Indigo cyclohexane models win hands down. Change your positions so you are holding atoms 1 and 4. You can move the structure through a continuous series of twist boat conformations representing unstable higher energy states such as those caused by heating.